Good morning, our dear parents. My name is Nasrin Maikiso and I welcome you to the Sir Apollo Kaggwa Primary School Mengo 2025 exhibition and P.7 graduation. Today, my colleagues and I are going to talk about energy and electricity. Energy is the heartbeat of modern civilization. From the moment we wake up and switch on the lights to the time we cook our meals or charge our phones, energy powers every part of our lives. But the story of how we came to use clean sources like the hydroelectricity and solar electricity is one transformation, a journey from small beginnings to advanced innovation. In the earliest days, human beings used to rely entirely on firewood. It was our very first source of energy. Firewood provided light, warmth, and means to cook food. However, as populations grew, forests began to disappear and people searched for alternatives. That led to charcoal, a more concentrated and efficient form of wood energy. Yet even charcoal produced smoke and polluted the air, reminding us that these natural resources were limited. With industrial progress came new fuels such as paraffin and gas. Paraffin lamps provided light to homes long before electricity, and gas, as you can see, this gas became a cleaner and more convenient way to cook food. Later, we discovered biogas made from decomposing organic waste. That marked a turning point. Humans learned to recycle nature's own materials into usable energy. But as technology advanced, so did our awareness of environmental challenges. We realized that many traditional fuels, though useful, contributed to air pollution and climate change. This understanding sparked a search for a sustainable and renewable resource. That search gave birth to modern energy solutions like the hydroelectricity and solar electricity. Hydroelectric power harnesses energy from moving water, rivers, and dams, converting its kinetic energy into clean electricity. Solar power, on the other hand, captures sunlight using solar panels and transforms it directly into electrical energy. These sources do not pollute the air, do not run out, and symbolize progress of human innovation from burning wood for heat to using water and sunlight to power entire cities. In conclusion, the story of energy is like the story of human growth, a continuous evolution from firewood to the future. Each step taken reflects our creativity and responsibility to protect the planet while meeting our energy needs. Thank you for listening to me. Allow me to request my other colleagues to continue from there.
Good morning, everyone. My name is Naigama Sicharabo, and today we have our hydroelectric power plant. Today, our main source of water is going to be this pipe. This pipe is bringing the water into the reservoir. This structure here is a reservoir. A reservoir can be a lake or a swamp. The use of the reservoir is to hold the water that will later be used to produce electricity. Now, since the reservoir is full, the water will automatically pour out. But the water in the reservoir has gravitational potential energy. As the water flows out of the reservoir into the penstock, this structure is the penstock. As it flows into the penstock, it starts moving. Therefore, the gravitational potential energy changes into kinetic energy. As we keep going downward into the penstock, we find the turbines. The water from there strikes the blades of the turbine, causing them to spin. Therefore, the kinetic energy we had there changes into mechanical energy. Now, our turbine is connected to the transformer. The transformer that is connected to this transformer. The transformer uses electromagnetic induction to change the mechanical energy into electrical energy. Now, if we switch off the motor, the turbine will stop spinning. Therefore, electricity won't be produced. So when we turn it on, the turbine will continue spinning, therefore producing the light we see above. Thank you for listening to me. Let me hand over to my friend.
My name is Virunji. I'm going to explain how the transformer transmits electricity to our homes, schools, and industries. As you see here, we have a step-up transformer. A step-up transformer increases voltage. After increasing the voltage, these electric wires help to transmit the increased voltage to a step-down transformer. This can work as step-down and step-up both. This one, if it's from 0, 24, 48, 220, it's increasing. From 220 to 48, 24 to 0, this is decreasing. So we need it here to work as a step-down transformer. The step-down transformer reduces the voltage which was increased from there. After decreasing the voltage to safer levels, these distribution lines help to distribute the electricity to our home, schools, and
Explain what Mercy said. The process of making electricity involves different energy changes, from gravitational potential energy to kinetic energy to mechanical energy, then to electrical energy. You might be wondering the definitions of the terms I have used. Well, gravitational potential energy is the energy possessed by an object due to its position against gravity. Kinetic energy is the energy possessed by a moving object. Mechanical energy is the sum of potential and kinetic energy an object uses to do a particular work. Electrical energy is the energy produced by charged particles. Through these scientific processes, energy from falling water is transformed and transmitted to power our daily lives. Thank you.
Good morning, everyone. Before you is Engineer Nisha. I'm going to talk about wiring in electricity. Wiring refers to the system of conductors and connections through a device or a home. Conductors are connected correctly so that they can produce electricity. During wiring, our main emphasis has to be on insulators and conductors. Conductors are materials that allow electricity to pass through them. Examples we have all metals and water. Insulators are materials that don't allow electricity to pass through them. For example, we have rubbers and plastics. That's why all our wires are insulated with rubber. During the mopping of the house, we should switch off sockets and switches so that we can prevent electric shocks. Let me hand over to Engineer Eto to talk more about wiring.
I'm going to talk more about wiring. Methods of wiring we have conduit wiring, surface wiring, and underground wiring. Conduit wiring is where wires are put in protective pipes. Surface wiring is where wires are put on the surface of walls. Underground wiring is where wires are buried. Common wiring systems we have ring circuit. Ring circuit is used in homes for sockets, and radius circuit is used for fixed appliances. I would like to hand over to Engineer Ahmed.
Good morning, everyone. My name is Ahmed Rashid, and I'm going to talk about passives in electricity. So here we have the meter box, which contains the circuit breaker. The circuit breaker breaks the circuit in case of high voltage. When it's off, electricity is only from the source of electricity up to there, and when we turn it on, electricity flows to the rest of the house. From there we have the earth wire, which goes deep in the ground. In the ground we have copper, charcoal powder, and salt with water. Salt and charcoal powder prevent the copper from rusting, while the water keeps the copper cool. The process from there up to there is called earthing. Earthing prevents electric shocks and fire outbreaks by providing a safe path for electricity to flow in case of a fault. Let me invite.
As he said, this is a metal box that has a circuit breaker. When it's turned off, electricity remains at this point. Then when it's turned on, electricity flows to this point. Then electricity flows to this wire, named the load wire. It is 10 millimeters because it carries current to two different wires, the 2.5 millimeter wire and the 1.5 millimeter wire. The load wire is 4 times bigger than the 2.5 millimeter wire, which takes current to the socket. Then current moves to the main switch. The main switch has two circuit breakers, one for the switch and the other for the socket. The one for the switch has C6 because the switch is not used as much as the socket, while the one for the socket has C20 because the socket is used in many activities such as charging phones, as you can see, ironing clothes, and it is also used in washing machines. Let me hand over to Andrina to speak more about electricity.
Thank you. My name is Andrina and I'm going to talk more about wiring. Here we have the main switch. It has two circuit breakers which help to break the circuit in case of high voltage. Here we have the 2.5 millimeter wire. It is 4 times smaller than the load wire because it carries less voltage to the socket than the load wire. Here we have the 1.5 millimeter wire, takes current to the switch. Here we have the strip connector which helps to connect the two wires. Here we have the junction box where the wires meet. When we are wiring, we make sure that we connect the neutral wire of the wire that comes from the main switch and the live wire of the wire that comes to the switch, so as to help current flow from the main switch to the switch. And we also make sure that when we are wiring, we make sure we connect the live wire of this one, of the wire that flows to the bulb, and the neutral wire of the one that flows to the switch, so as to help current to flow from the switch to the bulb to help it produce light.
Engineer Andrina. My name is Nareso Ilham Hassan, the engineer. With me here, we are going to talk about the dangers of electricity. Electricity leads to death of people. Electric shocks lead to death of animals. Electricity leads to environmental destruction. Thank you very much for listening.